Alright students, welcome back to question number 4 in surface areas and volumes. A solid cylinder of height h 45 centimeters and radius small r equals to 2 centimeters is melted and is made into identical solid spheres of radius 3 centimeters each. So the cylinder has been melted and reformed into identical spheres. Then how many spheres will be made here? The number of spheres that are created here. That's a question. Let's get into the solution. So the first concept is volume of the cylinder, pi r squared h. R is given, h is given. And then we have the second concept, volume of the sphere, 4 by 3 pi capital R cube. Capital R is also given. And then finally the third concept is a conservation of volume. So initially you had cylinder that has been converted into n identical spheres. So the mass is not going to change here, but density constant because temperature is assumed to be room temperature, alright, initially and finally. So mass constant, density constant meaning volume has to be conserved. Initial volume equal to final volume. Initially cylindrical volume by r square h. Finally you have n spheres. Let's say n is the number of spheres created. So that will be n into 4 by 3 pi r cube. We need to simplify it. First cut off pi either side and then substitute the values given. Radius of the cylinder is given as 2 centimeters. Height of the cylinder 45 centimeters. N is supposed to be calculated and radius of the sphere given as 3 centimeters. So now you simplify 2 square is 4. 4 gets cancelled and 3 cube by 3 becomes 3 square. 3 square is nothing but 9. So then you go to the next step here. This 45 continues. N into this 4 gets cancelled. 3 cube by 3, 3 square, 9. And 9 5s are 45. And so 5 equal to N. Otherwise, number of spheres that are being created out of cylinder is equal to 5. 5 spheres have been created here. So that's the answer. Thank you very much.